Um, okay, so let's start. So, welcome all. And today, again, we have a special guest. This time, we have Hazel Weekly. And I'm really happy that Hazel agreed to join us because I was following the works on the blog and also, like, as we'll discuss, the challenging part of running Mastodon server. But today we will be focusing on the observability, and Hazel wears many hats besides being, as I mentioned, the infrastructure witch of Hakiderm, a popular Mastodon instance. She's also the director on the board of Haskell Foundation, and she's also like really into observability, and she's also the principal architect. So I'm really happy that you agreed to join us. Thank you a lot. Would you like to tell a bit more besides what I talk to our viewers and listeners?
Sure. So I'm actually really happy to be here and I'm going to have a lot of fun chatting. I wear a lot of hats. I have a lot of thoughts. They never stop thinking. They never stop thinking. And I also am the first fellow of the Nibbling Foundation, which is a nonprofit focused on trying to understand and figure out how to teach the open source community and the world. How do we go from a project into a community and into an ecosystem? Because it turns out every evolution is this massive cliff, and you just get there, and then nobody's taught you how to scale it, and nobody has any tools for you or assistance, and so you just kind of flounder. And so many meaningful, worthwhile, beautiful projects or communities end up dying because they just don't know how to navigate the complexities of getting beyond a certain threshold. And so
Mhm.
I'm trying to help figure that out.
That's cool. And that's what we are also today here for. But thanks for mentioning that, because as we discussed before the recording, the first time I saw you and the team, so the further foundation, was when I joined the Hakiderm Mastodon server after the Twitter start to sync. But then immediately you got also like a huge amount of traffic, which in my opinion shows kind of pretty well why do we need the observability and monitoring, because that was the time where many people were starting to try the Mastodon or other um, Fediverse tools, but it appeared, of what I saw at least from outside, that they were not entirely ready for running on such scale, especially that your server got a really big traffic from many people from IT world that joined. Could you tell us a bit more? Because from my outside perspective, it looked like it's you build something for the community, and then the tooling was not there, the scaling part was not there. It was hard to understand what's happening inside. Was it really like a black box?
Yeah. So, for perspective and context for some people, when we first had Hackaderm, it was originally for Christinova a toy project. So she had her servers in the basement, and they were running whatever. They had for the file system an experimental developer fork of ZFS with weird, debugging parameters and experimental things and hacks on top of it. There was Kubernetes running a bunch of custom weird nonsense things. It was a hacker toy playground. And there was absolutely nothing on that entire set of machines that was production ready in any way. And she decided one day, I'm gonna play with Mastodon because Twitter isn't looking great right now. And let's just play around. And so she had a couple hundred people on it, but not a lot. And then all of a sudden, By the time I joined, there was about 700 people. And then in November, we went from 700 to 5,000 in 1 week. And then we went from 5,000 to 15,000 in 1 week. And went from 15,000 to 25 to 35 to 45 to about 55,000 people at peak in, 4 weeks or so. And so that is true, exponential scale. And when you hit real exponential scale, one of the really interesting things about it is you don't know what's happening until it's too late. And so
Yeah.
that's exactly what happened. We had no idea we would get the momentum we did. Well, we would have prepared a couple weeks sooner. And had we prepared a couple weeks sooner, we may not have needed to do a whole bunch of things. We may have completely prevented the entire week-long incident that happened. But instead, we were slightly too late, and then we ended up chasing the exponential curve the whole way up. But in terms of monitoring and observability, that's a tricky one. So and I hate the term root cause, but the root cause, quote unquote, of the whole thing falling over was, besides some inefficient tuning or some, system, whatever, we had two failing hard drives. And so the two failing hard drives caused the disk to be really, really, really slow. And it caused a lot of disk errors. And so you had the database, and you had Sidekick queues, and you had Mastodon, and you had everything doing a whole bunch of file system calls on a failing hard drive. And we were doing the simple, naive default solution for Mastodon, which is NFS. So it's a networked file system between all different computers. And so NFS requires that you make a whole round trip with a file system call. And you do this sort of synchronization thing, and it ends up being really terrible for a whole lot of reasons. But primarily, it's because you don't want the network to be a bottleneck, but you definitely don't want the disk to be a bottleneck. But they have to be really fast. And our disks were not fast because they were feeling they were broken. And so we were getting like maybe 11 to 20 IOPS, which are, IO operations per second,
Mm-hmm.
which is,
Yep.
these disks were rated for, I want to say, I don't know, 200,000, 500,000. So it's somewhere around there. They're solid-state drives. And to go from, the 200,000 you should normally have to, okay, you stripe it, you rate it, you whatever, maybe half that, to 30? You can't scale a system on that. And it turns out social media does this thing where you read from the disk constantly because the disk is where you store the media. And so people look at images, and they look at emojis, and they look at all kinds of weird things you wouldn't think that are on the disk but aren't. Like your favorite button, that's on the disk. That's the disk read. Your So it's this, and you're serving the web server from the disk. You're serving everything from the disk. Everything is hidden in. So for it to be the bottleneck caused so many cascading failures, it took out the entire system. And when we ended up doing a partial migration to Europe, we kept the NFS. So now we have a failing hard drive. No way to really find out that it's failing. And we're doing transatlantic NFS, which is adding 10x the latency on top of a very, very slow and failing file system. And if that file system has to repeat a system call because of errors, ooh, that's a round trip every time. So that made it so much worse. The fact that Postgres did not just completely fall over in that scenario was a wonderful piece of software. Um, but yeah, if I look back at this, and this is a long answer, but if I look back at this, and I think, how can we have known? It's easy to look for the answer if you know what the answer is, right? It's easy to look for the answer if you have one or two different things. And we were intentionally running the simplest, kind of most naive type of solution we could. And we still, a team of world experts at this, missed it for a week. Um, like I was actually the person who kind of noticed that our Grafana like graphs were weird and wrong for the file system. And but like we still all missed it for a week. But I think the biggest thing that it really, really comes down to is open telemetry would not have solved this particular problem. Or wide events and wide spans would not have necessarily solved a particular problem. The problem was really that we were able to see all the individual pieces and we were able to kind of look at all of the different ones, but can you correlate the different bits of information to create a coherent story in the system of what's happening? That's really hard. And if you can do that, that's a superpower. And OpenTelemetry gets you that, but in a certain way. It's really the magic is not the wide events, which a lot of people think it is. The magic is actually the correlation.
Yep.
Can you correlate the data in different ways? And the wide events make it easier. The most open telemetry, like most observability and instrumentation people implement, doesn't put, say, the amount of web traffic together with the what you're doing to the sidekick or to the database, and they don't put that together with what are you doing to the file system, and they don't put that together with okay, but what's the actual system performance at this time, and getting all of those together is what we would have needed to look at this and go, oh, every time we get this massive backlog, it's because our IOPS and performance of the drives crashes. The 2 out of 5 or 2 out of 5 drives are broken. So if you try to read one of the broken ones, that's not going to work. But how do you know that without carefully crafting that together?
Yeah, that's also like my I'm not sure if concern is the good word, but to be able to, because most of the advices that I see on the internet about how to apply open telemetry is just put as much data as you can, because you can't predict what you're gonna need in the future. But then to be even able to correlate, then you cannot just throw data in, because in my opinion, to some degree, you will be getting the classical issue of the garbage in, garbage out, plus extreme extrapolation of the costs. So do you have some hints how to design, those, at least on this instrumentation strategy, to be able to correlate this data? Because of what I notice, the main challenge that people are having at the beginning is quite close to what we had in past with logs. So how to structure the data so we are able to get the answers and to ask the questions in the future. So how to correlate the data, as you said.
Yeah. So that is a really interesting question because every observability vendor is going to want to say that you can do this. And they're all of them, insufficient in certain ways.
Mm-hmm.
But whether or not those ways matter for you and your business or your project is very, very, perhaps even individual. And so it's hard to give a recommendation. But if I look at the observability history and tie that together, I'll take you through that and then that'll help.
Mm-hmm.
So Charlie Majors came out with an observability 1.0 and 2.0 reframing of the what is observability question, because historically that was sort of a way to help contextualize the what are wide events and why do they matter. And the way I actually like to think about it is not really about the 1.0 being one type of property and 2.0 being wide events. So like the way Charity talks about it is 1.0 is many data sources and non-correlated data. And 2.0 being as a defining feature, everything is in, one type of data and you just shove it all in there,
Mm-hmm.
which is close, but they both focus on the technology and implementation choice rather than the business benefit. So to me, Observability 1.0 is when the types of questions you can ask your system are picked when you ingest the data and or create the telemetry. If you're sitting there going, this is going to be a metric, you pick it, you send it off, you aggregate it, you ship it into a Prometheus endpoint, it gets scraped, you send it off, right? Or you send it to Datadog with them, or you send it to any vendor as a metric or as a log. You pick at ingestion or creation time the questions you're going to ask or the capabilities you have. Observability 2.0, the fundamental shift there is the question is pick the query time. You can do everything with both, but it's the mindset of do you pick the question at query time or when you create the data? If you pick it at query time, you have to bias really hard on sending more data than you think you need, but
Mm-hmm.
it has to be useful data, which is where a lot of people run into a problem. And so for me, the thing that makes this framing better, well, not better, but nicer for me, is if you think of a question you pick at the query time, a question you think of when you're looking into the system, then the answer you think of is not, well, how do I pick what data to store? It's what data will let me ask more interesting and meaningful questions. So if you're doing Ruby on Rails, you probably really care about the queues. You probably really care about the database and you care about the endpoints. And because it's, an MVC, you want the endpoint, like, the model, the view, and the controller to be correlated together because they're, one kind of unit and need to trace that.
Mm-hmm.
And then in there, it's almost always a database call and almost always some sort of queuing call. And so you really want to be able to link those two together. So now I can go, okay, what will help me link the queues to the MVC to the database? If I can get those three linked together, then I have a really, really strong foundation and like starting point. And then you're starting to see one of the challenges with observability 2.0 and wide events, which is that you can't actually stick everything in them. You want to, but things like profiling data or performance data or some types of system data doesn't make sense to stick in a wide event.
Yep.
Like if I have a wide event that represents an endpoint of fetch a post, what does CPU utilization look like? Is that a one-time snapshot? Is that like what? CPU utilization for the whole duration of this is actually useless information because I want to know not just this call, but this call, minus 30 seconds after 30 seconds.
Mm-hmm.
I want something that's disconnected from the span but correlated. So that's where I get into, and I'm going to write a blog post on this soon, but I have Observability 3.0 that I think about. And so the fundamental defining feature there is Observability 3.0 happens when you focus on the business value and the business context. And you take your system and you are able to frame it in terms of the business value. So,
Mm-hmm.
for example, one of the huge problems we ran into with Mastodon and scaling Hackaderm is the queue design of Mastodon is not typical to what you would do in a modern application now. So in a modern application now, really good queue design focuses almost entirely on the performance profile of the queue. And you break up all of your topics or all of your messages, and you know this from event streaming. You break a lot of things up, not necessarily into semantic topics, but you
Mm-hmm.
break them more up into I need a response within a minute, or I need a response within a day, or this is, you know, what are the performance characteristics of the queue that you care about? And that's a lot more useful 90% of the time than I want to put this in the add a follower queue or post a message queue. And Pachyderm is focused on that. So Pachyderm or Mastodon rather has like a queue for the federated stream. They have, which is new. They have a queue for posts, something for immediate processing, something for like messaging, basically a semantic topic, which is useful when you're developing. Because you
Mm-hmm.
can just write out submit job to blah 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 the job queue or submit post in the post queue. Super useful. But it means that when you're trying to scale things up, what I would have to do is I figured out what all the queues were used for, what the perceived performance of the system was, and then optimize the queues to degrade unimportant performance in order to improve the perceived performance for people.
Mm-hmm.
For example, the federated feed is by far the most compute intensive thing in the entire Pachyderm Mastodon like thing. It's a massive fire hose. It almost always involves pictures, which involves downloading things to disk, re-encoding them to disk, saving them, uploading them somewhere, and then serving them out. It is a huge computational drain. But people generally don't care that much. Like, unless you go to the federated feed, your the federated feed is stuff that you don't follow, stuff that you're not directly interacting with, but it's related to something someone else is doing somewhere in your server. And do you follow them? Do you care about that? So the federated feed can lag 6 hours behind where it should, and barely anybody's gonna notice. But if your post takes more than 10 seconds to fire off when you submit it, you're going to have a fit, because that is going to break your experience. So before, um, but before I want to say 4.1 or 4.2, we could not just split those two up because they are all posts. So if I wanted to submit a post, I had to take care of the whole federated feed, and I had to handle all of that traffic in order for you to post something rapidly. And that meant that the system was just super inoperable because we needed to over provision, everything needed to work great. You had to handle massive bursts of traffic just so that people had their interactions performing. When we focus on the business value, you can go, oh, this queue takes up 90% of the server time and offers 10% of the value. We're going to rebalance that. We're going to turn it all the way down so we have more space over here. And that's great. That's awesome. You should be able to do that. And if you think of the business value in the context and you start answering questions that are meaningful for the wider business, not just for the engineering team, that gives you so much insight into what do you actually need to do to monitor your system, to improve it, to get that performance where you want it to be.
Mm-hmm. Yeah, I like that. On your blog article, you also even provided like multiple questions from multiple people, like an engineering director. So, for instance, that someone would like to analyze the trade-offs and reliability of our system of specific parts. So we could, so they could maximize the value delivery and all that stuff. So mm, I like your answer. I fully agree with that. So then the question is, because for me it's like we have a different two forces, distinct forces pulling on one hand and to each other. So what I mean by that, it's like on one hand we have this manual instrumentation crafted with the business in mind, and on the other hand, we have this unknown unknowns and storing a lot of data like from auto instrumentation, eBPF, and all that, tooling that can log entirely everything. And then we have the reality check with the vendor tooling. So even if you put, so the more data you put, the higher cardinality of your data is, because you have much different data that you cannot easily index, and then those databases, because underneath they are databases, they cannot easily scale to support those filtering and getting the answers to those questions. So from my perspective, it's like with this from Family Guy gif with the Peter Griffin that pulling this Italian and just broking one way or another. So do you think that we can somehow balance that? Maybe in mentioned by you observability, the next generation, so 3.0, because I think that for now we have a lot of let's say marketing, then we have this reality check of one hand that developers don't want to think about and put the observability as the centerpiece of something as part of their design, and then vendors that are giving promises but not delivering, at least not all of them those. So how can we somehow find some middle ground, or can we actually find some middle ground to support that? I know that it's a long question,
Mm,
but
yeah. I think there is definitely a middle ground that's possible. It does require some compromise and reframing on everybody's minds. So, kind of walking backwards, engineers are going to need to care a lot more about the system and the end users and how the business value actually gets delivered. It turns out that according to some research out there on developer thriving or psychological safety or high performing teams, a lot of developers actually do want to care. They're just incentivized by the business not to, or they're having the information hidden away, or it's reaching out to the customers is not your work. And you have, your work to do and you need to be high performance. Or a lot of how we think about developer productivity is directly countered to developers understanding the business needs and the business value. And so then developers don't understand that they have this disconnect. And then they don't necessarily want to do the thing because if they're worried that they might get fired for low performance, why would they spend time on something that is explicitly labeled as low performance?
mhm.
So that's developers need to care, but they also need the system to allow them to care.
Yep, I agree.
And engineering leaders and business leaders need to understand that there is a thin line to walk between motivating developers to care and then giving them so much rope and slack in their schedule that they spend their entire time just discussing things, talking with customers, not really sitting down and delivering stuff. So you do want this rapid iteration and feedback. You want the feedback loop to be complete, and you need the appropriate motivations and pressures in the system to keep everything tuned. And it's a really, really hard balance.
Mhm,
But then walking back a little bit to the vendor promises and everything else, one of the things that's tricky there is you have the history of OpenTelemetry and where it came from, and the history of distributed tracing, and then the mismatch of how companies can implement it, which leads to a very different usage pattern and shape of data.
mhm,
So walking all the way back, distributed tracing used to be entirely manual. You had no such concept as automatic instrumentation. And so a lot of people discovered that columnar databases are an ideal use case with a fork join pattern of querying the database in parallel, stuffing everything into a column, and then you don't need indices. Everything is super fast. You can just grab the data, you can pull it out, and all of the first observability systems out there in places like Meta or Google really emphasized that kind of construct of manual traces and this columnar database where you can slice and dice. Those three things.
mhm,
But it turns out very deeply embedded in that slice and dice of the columnar database is the assumption that because it's a manual trace, you really only have about one or two spans for the whole event
yep,
from the end user perspective. Like, the API call, and everything's on that one span. And then if it calls out to another microservice, everything's in that one span. And if that calls into another microservice, that one span. And typically it's microservice, microservice, and they're not nested necessarily. So the depth intrinsically is about 3. If it's anything further than 3, it turns out OpenTelemetry and all the distributed tracing stuff really starts to get very creaky. And then if you want to instrument the front end, well, that's another layer. And so the front end means that the back end can only be of depth about like 1 or 2. Otherwise, you're just not going to have enough room in the span to handle the front end and its complexity and the back end and its complexity. But if you think of that and you're probably thinking to yourself, I've never seen a trace with that few levels of nesting. That's because of auto instrumentation. The auto instrumentation and the SDK and the design of OpenTelemetry make it really, really hard to collapse the tree. So what ends up happening is you end up with a super common situation of the backend is auto instrumented, which means you have a span for starting the runtime, you have a span for an endpoint, you have a span for processing things, you have the generic HTTP framework, you have your framework, you have the middleware, and then you finally have your logic and you're already like 15 levels deep. And you can't collapse that very easily, which makes the slicing and dicing ironically very hard.
Mm-hmm.
Because you need to join different spans and you
Yep.
can't do that in a columnar database. So the whole premise of observability starts to fall apart. If you use automatic instrumentation, you have to really, really dial it down and be very careful about how you use it. Which doesn't, seem like a problem, right? You just write the automatic instrumentation and then eventually swap it out with manual instrumentation or you curate it or you, and that also poses the second assumption, which is that you have full-time people working on observability that care deeply about it, that are willing to be an expert, and that want to dig in and understand the system holistically. Which turns out, product developers are almost never given the time required or the permission required to work on tech debt or observability or any non-feature work. So, of course, they're not going to be these people.
Mm-hmm.
The, DevOps platform kind of people have the whole company to support. If they try to work on an individual application, they just never get anywhere. And so they are really, really looking for a one button, hit the whole, enterprise, hit every application, do something. And they also don't care about the business value because to them, well, they don't care about the business value from the perspective of the product developer. Because the business value for them is the product developer, not the customer. It should
Yeah.
be both, but it's really hard to have that.
Yeah, and also quite often the decision makers in terms of which observability tooling to use are the SRE or ops people, and then developer are asked to just align with those decisions, which is also challenging.
hmm Yeah, and if a developer is more comfortable with one tool versus another, that
Hmm.
often just doesn't matter a whole lot
Hmm.
because the tool was already chosen for maybe security or regulatory reasons. Maybe you got to deal with the vendor, maybe, and there's about a million different reasons where this could be happening that have almost nothing to do with how useful is it.
Yep.
And so yeah, it gets very challenging. But in terms of concrete things, in terms of sitting down, doing stuff, there is a person, Jeremy Morel. He
Hmm.
wrote a blog post called A Practitioner's Guide to Wide Events. And
Yeah,
it is
that's a
actually a
great
very,
one.
very good article on,
Yes.
mhm, yeah, it has a lot of actionable advice, but it also starts from the middle of the story. It starts from you have everything set up. So if I'm coming into a company and I'm looking at the company right now and they say, I don't have observability, where do I want to start? The first question is, what are you running for your infrastructure? The second question, which you ask at the same time, is what hurts the most? Like you should not start your observability with trying to get a good picture of things. You should use it to immediately solve a business problem. So are all of your ops teams ready now because of on-call on the system? Cool, that one. Are, is one system losing sales deals because the system is unreliable? That one. Start with that one. Is like, what's the pain point for the system? And then what's the pain point for the business? And what's the pain point for the operations or platform team? Identify those two, make them as similar as you can. Ideally, make them the same, and then solve that problem first. And then if you are running Kubernetes, like most people are at this point, then you should probably install the OpenTelemetry collector, Grafana, Prometheus, a couple other things. Just install it. And then with the OpenTelemetry collector and the OpenTelemetry operator, hit everything with more or less useless data. Just grab something from everything, and then start shoving it into the collector. Take the collector, shove that data into into an on-prem visualizer, and then to see what the hell is happening. Once you get the data to almost close to useful, just without talking to the product teams or without talking to anybody else, then figure out the shape of that data, figure out what works for you, what works for whatever, and then start to use that to inform, okay, we need a vendor. Let's reach out. Here are, our constraints and what we need. Here's our expected volume. Here's our so on and so forth. That helps you a lot with helping negotiate and make sure that the vendor that you pick is one that's actually going to suit the developers and the business. And turns out you don't necessarily want to involve the product people yet because the business incentives are rarely aligned for that. If you involve them too early, you're going to switch tools on them. A lot, you're going to putter around and break the workflow. And this is a time of experimentation and need to solidify a few things before you really involve them. Let them know. If they're curious, they can come in and join. But don't necessarily ask them to come and join before you're ready for them. And then with the product teams, the most successful method that I've ever seen for the product teams is to grab headcount, either from the product teams or from the ops team, just for a whole quarter. This headcount allocation does absolutely nothing except go through every single code base and set up the default instrumentation, set up the default things here and there, maybe write a little wrapper library or something, and then do manual instrumentation in one part of the app. Usually the login page. So that you can, take the login page and you can take a session ID or a user ID or something, tie that to a persona of something in the sales team, and then put that on the root span. If you do that one thing, and I mean that one thing, your sales team will love you forever. And your business team and your product team, like everybody will love you forever. And here's why. You can use that persona thing to identify the whale, your whale customer, or your very, very high value customer. And you can slice and dice things by high value customer or by customer segment. If you can do that, that immediately gets the business to understand, oh, this nerdy engineer thing can help us understand the system from a technical point of view and a business value point of view. But the teams will never have time to do this. They will never, like, if you ask them to do it, it'll take months, it'll take quarters. So you have to just say, we're going to grab a couple people full time, run through, and have those people do absolutely nothing but this auto instrumentation over, but the manual instrumentation and the setup just over and over and over and over. They're going to get sick of it, and they're going to get tired of it, but they're going to get really efficient at it. And they're going to just rip through the code base, make a whole bunch of pull requests, and do that. When that happens, when that's through, when that's done, you are good to go. The second piece of manual instrumentation you should probably put, if your auto instrumentation doesn't already cover it, is what git commit is this code. Super useful. Almost nobody puts it in there. But between that and the customer segment, everything else can be later. But once you set up that skeleton and developers can low effort see the code and copy paste it and do their own thing, you are good to go. It won't start happening. You've lowered the barrier of entry. And that is the magic of observability, is lowering the barrier of entry. If it's too high, people are never going to want to sit down and understand it. They need to almost accidentally be able to learn it rather than have to dedicate time out of the way.
Yeah, that sounds great to me. That's a great piece of advice. Thank you. Uh, it's also quite aligned to what Gojko Ajic in the previous webinar told, that for engineer, uh, if someone is thinking like whether it's useful or not, or how maybe even to get into the discussion with the product people, is to give them data. And the what you said is a really good starting point on having those meaningful data for both sides. So definitely
Mhm.
I really like it.
Yeah.
So about this, also this connection, because I'm coming from the event sourcing, event driven community, and there is a overlap in thinking about events, because here in event sourcing we have those, let's say, business events, and in telemetry we have events which are kind of looking similar, because we should also put a lot of context. We can also use both of those events to make the business decisions. The regular business events should also be correlated, because we should know like what's the order and what's the business process behind them. But to me they sounds a bit different, even like from the perspective that you mentioned. From how I see most of the people are doing telemetry, then they have those traces polluted with the technical information, which is fine for debugging. But if business is coming to us and asking, like, hey, could you tell me how much, let's say, dropped basket do we had in like last 5 days, or what was the, let's say, potential reason for that, then if we if we have those pre-aggregated by some traditional BI, then that's easy. If we have some solution like big data for events, we can also query them. But can we, or should we use like telemetry data, in your opinion? Or how do you put the difference between, let's say, traditional events in terms of event-driven way and those from open telemetry and observability tooling? How would you put the, mm, let's say, differentiation between those? Or maybe there is no. What's your take on that?
So I think my take on that really is more, and I'm actually going to ask you a question on this, which
Okay.
is, if I think about an event in OpenTelemetry,
Mm-hmm.
what I'm thinking about is my definition of observability is a process through which one learns to, a process through which one develops the ability to ask meaningful questions, get useful answers, and act effectively on what you learn. So
Mm-hmm.
every time I'm doing an event, I'm thinking, what are the meaningful questions I can ask for this? What can I expect to learn? And am I going to be able to take action on that?
Mm-hmm.
And then in event-driven design, when you write an event, what are you thinking of?
So I'm always saying that I'm ask. I should start with asking what actually has happened and record all of the meaningful data about what has happened in that event. So all the potential business context. And then there are some stuff that you like known knowns and unknown knowns, so those stuff that you can prepare. So let's say for now I know that I need it for this read model, that read model, and this aggregation. But then in the future, if I have this data, then potentially as the business grows, then I can be building other type of aggregation or doing some data drilling. So that's why it's important to think, in my opinion, of what has happened, not as many people frame it, what has changed. Because what has changed is already interpretation of what has happened. And that's losing the business context, in my opinion. So at least that's how I frame it and try to explain to the people. So it's kind of similar, I think, but more focus
Do you
on the
frame it as
business, more for getting insights rather than not necessarily debugging, how telemetry is quite often promoted by the people.
well? So you mentioned insights, and to me, the insights are really also at the heart of OpenTelemetry
Mm-hmm.
or just observability in general. It really is about insights as well. So I'm curious, and I'm going to dig in on the insights. So let's, for example, talk about a system in which someone is buying groceries. From what I read online, a common mistake people do is something like they create an event of, purchase basket.
Mm-hmm.
And the purchase basket event is going to have the whole list of items, is going to have everything, the payment date, and they do a whole bunch of stuff in that one event.
Mm-hmm.
And but usually at that point, most event-driven domain people are saying that's not quite how you want to do it, right?
Yeah.
What
So
is the difference between like a common mistake people make and then how you usually want to do it?
mm, I think that there is a gray line because I'm always saying that events should be as small as possible, but not smaller. And it's hard to say precisely what does that mean because many people believe that if you put a lot of data in the event, then you will have more information. But then if you put those potential redundant data, then actually it might seem counterintuitive, but those events become less precise because each time you look on the data, you need to think whether this is a this is something that actually has happened and that's really related precisely to. So to give you a practical example, let's say that for user you would be always storing their names, or for address you would store completely the full address. And then if you have some events like, let's say, profile updated or whatever, and if you try to put all of the data, then you will always need to try to guess whether this actually happened, this how does relates, or maybe you just put it additional data because it was easier for you to make those aggregations. But then those events, even they have more data, then they are becoming less precise and actually are gathering less information, less precise information. At least that's the most common mistake that I see in designing the payloads or the structure of events.
Yeah. So that actually relates a lot to me in terms of ability because so you mentioned this concept of, and let me know if I got this right. You mentioned
Mm-hmm.
this concept of you have you have payloads with maybe too little information. That's
Mm-hmm.
totally a thing.
Mm-hmm.
But you can also have too much information in a payload. And when you have too much information in the payload, you can no longer reason about the payload,
Yes.
sort of in the context of a stream, which that's really important to me because if I think about like this event stream, I want to be able to read it almost like this log of events that happen, because that's what it is.
Mm-hmm.
And so if I read it and I go through it and I see updated profile and the whole profile, did that update it? Is that what I need to update? Is that, and then what if I get two events in order? And one is update profile and the other one's update profile, but
Mm-hmm.
they're actually misordered? Well, which one is the real one?
Yep.
Or so how do you think about that? So like for me, the way I can think about how to guide myself to the better design for observability is considering what the most meaningful questions I can ask are and how to ask them. Because I
Mm-hmm.
can send too much data. I can send data where I compute a whole bunch of information and I send it in there and it ends up being really, really not useful
Mm-hmm.
because I have, the source of truth and the derived data and then the derived data. And
Yep.
then, but so I can guide myself to a better example by asking what's a meaningful question. So how do you ask yourself a question that lets you know that you need to refactor an event payload? And what is that kind of question that lets you gauge whether or not one payload is better than another in terms of design?
Mm-hmm. So I usually start with the smallest possible amount of data that is meaningful for this business operation. And then I'm considering um, other needs, like for instance, whether I know already that some other workflow can be triggered by this event, or maybe whether this event is part of my internal module knowledge, or maybe part of the should be, let's say, bigger if it relates to the whole part of the business process. So like the distinction between private and public events. So probably it's quite similar, I think, to what you're driving, is that i'm I'm doing some simulation of why I would need this event. So maybe for this type of read model, maybe for this type of workflow integration, or maybe I can have some sort of gut feeling, or let's say domain expertise, that this is the data that I don't need at this point, but in the future they might be really needed.
So how do you know, or how do you get that intuition on whether or not the data might be needed in the future?
Yeah, so that's a magic part. Unfortunately,
Mm-hmm.
it's like there is always this part where you cannot, predict everything, but you might try to guess. And then the guessing is, of course, either more or less correct. And uh, that's not quantifiable, at least in my opinion. It's hard to say. Like, besides
Mm-hmm.
talking with business people and people that have more knowledge or more expertise, it's without talking to them, it's hard to say whether you will need them or not.
Yeah. So let's dive into a concrete example. You mentioned previously an update person kind of
Mhm.
event. So what if I'm designing a system and I'm thinking smallest possible event and have a form field. And for the update form field, I'm going to, for every field, basically have its own update event. So if I have the, user, if I have the name, it's going to be an update name event with the user ID and then the new name. Is that a good event?
Actually, not, because then it would be like a property sourcing. So you would have extrapolation of events. So typically, I mean, those types of event are more state based. So I would typically group them with some category, like personal data updated with information whether this part was updated, which exact fields were updated, because then actually business don't care whether the first name or last name was updated, but they care about, okay, someone updated their personal data, or maybe they changed their surname. So possibly that can mean that, let's say, they got married and change the surname, or maybe changing email is also property, but then it's usually related to more business information. So yeah, so that's also the example where grouping the data and giving making a bit bigger events can be more meaningful for business people.
Yeah. So then here's the next follow up kind of really fun one. So I take care of it
Hmm.
and I say I'm going to have an update profile event. And I'm going to just stick all the new fields in the update profile event, only the changed ones, not the
Hmm.
rest of the profile, just only the changed ones. And then I'm also going to, if they update their credit card information, like their billing information, the plan details, or anything associated with the user account, that all goes in there.
Hmm.
Is there a problem with that?
Yeah, I would typically break them by the business context because changing card information is usually uh, important. Sometimes you can trigger some fraud detection and so on and so forth. In general, like profile updated is not great type of event because it doesn't give a business context about what has happened. It tells what has changed, which is not like, of course sometimes it can gather some value, but typically business care about what user actually uh, intended to do and what has happened after this intention. So probably those events would be more like payment method uh, changed or defined, or user removed the payment method, or maybe VIP status was assigned, or so on and so forth.
I love that answer because I'm going to take that and I'm going to tie that back to observability. You gave me the answer I was hoping you would. And so I'm going to pull the things out there that was really, really, that stuck out to me. We started with an event that was too small. And you're like, well, you're going to have, 100 of these every time you hit the update button. And that also has no meaningful context. The business doesn't care about that. They care about if the personal information was changed. And then I went too big. I said, what about the whole profile? And then, well, that doesn't give you, from the business context, a meaningful separation. Because if you update credit cards, that's a whole separate line. Like you need the fraud detection, you need the business context. And then also sort of the operational, what questions can you ask? Or how can you observe this? Or how can you think about it? And you started actually doing this observability driven design in it, even though it wasn't observability.
Hmm.
So if I take this back to observability, am I going to have a new span for every single field? No. Am I going to stick the whole profile page whenever I hit the update event button or update profile button? Am I going to stick the entire profile in that one span, including the credit card data? I mean, I better not. For one thing, you shouldn't stick credit card numbers and everything inside, your telemetry. Don't do that. Uh, but even if you did, you can sample it out. You can like mask and obfuscate it. But goodness, don't do that. Um, But it turns out that, like, profile information, personal information, maybe addresses, maybe the VIP status thing, all of those are useful and different. And so I'm thinking of the observability of this, like, user profile management. I want to know when people go to this page. I want to know when they update their information, like, when are they updating? What did they change? How frequently are they changing it? And then also things like, oh, if here's a really, really interesting business context question. How often are we getting fraud reports? How often are people changing their credit cards to fraudulent, credit card information? How much of those end up being typos? How much
Hmm.
of those, or if people, make a new account, how old is the account before they started adding credit card information? Do they almost always add information only when upgrading to VIP? Do they add it before? Do they? Those are really interesting questions. So you might want
Hmm.
to add that in there when you update stuff. And you want to carry that kind of information around with the user, sort of conceptually in the system. Then you can ask these questions that you're wanting to think about with the event-driven design. Because if I'm thinking about observing the events and I'm thinking about observing the cues and the behavior of, all this event-driven
Mm-hmm.
system, if you're an engineer and your manager says, "Hey, I had a question from my boss. He or she, she is working with everybody else, and they're trying to figure out how to prioritize the feature set." And she says, "How many VIP users do we have? How often are VIP people updating? Like, do we need to upgrade our credit payment plan to have faster vendor processing, or can we just say put a button on something that says your update will clear in a day or two?" How do I answer that question? I would like to be able to open up a vendor, tool or an observability tool and say, "Oh yeah, 20% of our user base is VIP. When they do the VIP, they almost always add the credit card payments at the same time.
Mm-hmm.
Very few other people do. So basically, 90% of the time we add credit card payments, it's for VIP people, and in the same session they purchase something. So they want that information to clear real quick. So yes, we should absolutely pay more for expedited, credit fraud checking or whatever in our payment system. That's useful. That's meaningful. And most implementations of instrumentation cannot answer that question. Most people never figure out how to phrase that question in their system, and they never build a system capable of answering that question. So then your director, she has nothing to go off of. She's going to talk to the engineers. The engineers are going to say, "I don't know. They're going to guess." She's going to take the guess and say, "This is a guess. I don't know. Anyway, we're paying $2 million a year for our observability stuff. We're going to need to upgrade that to $3 million a year because we're using more." And the entire rest of the business is going to go, "Cool story. Um, that's a lot of money for you can't even answer a simple question
Yep.
that we care about."
Yeah. So for me, the challenge is it's kind of related to both social stuff you mentioned, but also the technical part. As you said, like the vendor tooling, of course, some are better in those slicing and dicing, but in general, all of the vendors, if you ask them and nag them, then they will tell that they are designed to keep the data for a relatively short period, and they are not like durable. So, and then depending on your size of your wallet and your strategy, you might be losing this telemetry data pretty fast. And for instance, in event sourcing, you are intending to keep this data potentially either forever or at least for as long as you will need them. So at some point, I had a weird idea that what if we like put those business event directly in the telemetry tooling, because this high cardinality and the slicing and dicing, but then it always appeared that actually we are not there yet. And what's your opinion? Where would you put it in, like technically, in like different tooling, or how would you correlate those information?
So this is a really tricky question because it has a lot of different factors.
Mm-hmm,
A huge factor is when you look at the usage patterns of people and you look at the data that helps people solve real problems in the system.
mm-hmm,
It turns out that any data older than 3 days is probably useless. You're actually really just not going to answer a question about what's wrong in the system, out of it in anything, beyond 3 days. It's just too large of a context window. And so Lightstep, the company actually used to have a 3-day retention. Honeycomb has 60 days, and that's a huge selling point for them.
Mm-hmm.
Basically, nobody uses the 60 days. And even if you do, the answer is actually in not even 30 days, but usually 7. And if it's 7, it's almost always in the 3-day window. And even if it's in the 3-day window, it's actually 90% of the time in the 2-hour window. So in theory, the vast majority of your telemetry can be thrown away in 2 hours.
Mm-hmm.
The vast majority of what's left can be thrown away after 2 days. The vast majority of what's left can be thrown away after 7 days. And the tiny, tiny little bit that's left over is a rounding error. And also the volume of events that you're getting in telemetry is massive compared to event sourcing.
Yep.
Where like in event sourcing, you have maybe 100 events per second in a decent application.
Yep.
But by the time the application is that size, your telemetry, you're sending like 3 to 5,000 events per second. And so storing that forever, real hard. And also the payload size of the telemetry ends up being larger per event because you have more not duplicated data necessarily, but in a sense also duplicated data.
Mm-hmm.
And so things like all the different fields you can lead, you stick them in there. Well, event sourcing, you can really, really pare it down.
Mm-hmm.
Like I can put the user ID in here,
Yep.
but I might want 5 fields in the telemetry or the one field in event sourcing. And so the payload size is larger and the volume is 100 to 1,000 times more. Storing it forever is just impractical. But there are plenty of companies out there where their where their telemetry is and exceeds 1 terabit per second of volume. Are you telling me you're going to store 1 terabit per second of volume indefinitely?
No. Yeah. So my
Hmm.
my take is, how much is it coming from that people are just shoveling everything as they are told and not thinking what actually would they need? Because I understand that there are companies that will always have a huge amount of data, but my guess is that like average type of system, even like the let's say Hakiderm had a huge traffic, but I wouldn't say that probably it wasn't technically and business wise so complex system. Complicated, yes, but complex probably not. So do we actually like, is this amount of data that we put into the telemetry, is it coming from how we are doing stuff, or this is how it should be, like?
It's, I think, coming from a lot of different things. One is definitely the rise of auto instrumentation and the rise of adding everything and using it, and the rise of having multiple teams looking at the data and trying to make informed decisions from that does contribute a lot to the bloat of the size, but a lot of that bloat ends up being useful in the moment.
Mm-hmm.
So the trick is really, if you think of observability from that 3.0 perspective of what's valuable for the business, what you get is actually the recognition that you don't just want sampling. You do want sampling, but sampling is only part of it.
Mm-hmm.
You want multiple tiers of sampling, multiple tiers of aggregation, and this very, time delayed decay half-life look at the world. So like, for example, social media applications are super hard to build because they're a pathological case of usage of data. The half-life for whether or not something's going to be hit is like an hour.
Mm-hmm.
So the most amount of views happen in the first 5 minutes, and then the next 10, and then so basically for the first hour, you get like 90% of every view you're ever going to get. But then the first 6, it's like 3 nines. And then, but it turns out people might go, oh yeah, that one, image. from this one post from 12 years ago. I want to see that. And no, I don't want to wait 2 minutes for you to fetch it from, the warehouse.
Mm-hmm.
I want it now.
Yeah.
And so how do you reconcile that? And it turns out that, tiering is really important, but understanding the access patterns and understanding how things are used in different contexts matters a lot more.
Mm-hmm.
So like for observability in 3.0, what I would like to see more, which is something that nobody does yet, is understanding the different use cases of observability and consumption patterns of observability beyond just the developer debugging the system and being able to let you take that huge fire hose and input it in and understand that after about 2 days, that fire hose is going to turn into a trickle.
Yep.
And then you can keep that data longer. And then that trickle might get persisted in various different forms in certain areas so that you can do, for example, quarterly reports.
Yep.
But the quarterly reports are certainly not going to go over 50 terabytes of data. They're going to have 4 bullet points. So at some point, 50 terabytes of data needs to turn into 4 bullet points. And we have no nice way in any of our systems to think about what are those useful 4 bullet points of information for the different people in the system at different points in time. So you end up with store the whole fire hose. Or you do my favorite trick, which is you use the OpenTelemetry operator and the OpenTelemetry collector and use it in a distributed pattern. So you have a collector per node on your machine, and then you have a aggregator collector, and the aggregator collector grabs everything that has already been sampled with head sampling, been pared down, the data's been augmented and touched and correlated, and takes that and then does tail sampling. The tail sampling lets you see the whole trace and lets you understand the whole system and then drop irrelevant things. When that happens, that helps reduce the fire hose quite a bit. But then you do something that I don't see a lot of people do. You ship that off before you do the sampling into a raw bucket. And then you ship it off after you do your sampling into a refined bucket. And this sounds like a modern lakehouse type of architecture
Yep.
because it is. Take everything you learn from the data, observability community, the business intelligence community for the last 4 decades and apply it to this. The same
Mm-hmm.
problem. And so you should have like a raw ingestion, the, bronze, silver, gold. And then you can have maybe your gold is going to be actually 4 different buckets, and one of them is going to be a metric, so a summary or right, like whatever. And then you have long-term correlation, but you didn't pay buckets for it, buckets. But you also then need to break the vendor observability tooling to support a use case that nobody actually uses. We
Yep.
have the data where it's useful. And the best thing about that is if you take the old data and then you ship it off into, or like the gold or the silver, one of those two, and then ship it off into your telemetry vendor, your observability vendor, then you can actually see in real time and understand how, like, how effective your sampling is. Are people missing information? Are they missing data? If not, you can increase the sampling. If they missed the data, if they had to go back and grab it out of like a bronze or the raw tier, then you sampled too aggressively in one spot. And so that gives you a data-driven way to figure out how efficient you are with understanding the system.
Mm-hmm.
And lets you treat sampling as not just a cost-effectiveness thing, but actually as an SLO of how well do you understand the system. Because if you understand it super well, you can know exactly how it behaves and predict stuff really accurately and dig in and go, okay, guess what? We have this one page. We hit it all the time. It basically always works. We're going to sample this thing at 1 in 20,000. Except for this type of error, which usually we keep all the errors, but this type of error happens pretty often. We're going to sample out, 1 in 100. And you can start to really understand your system. And then if you misunderstand it, you can go back.
Mm-hmm.
But that lets you go, oh, the amount of times that we miss information goes down over time, and the amount of times that we were able to like cut information and not miss it goes up over time. So you should constantly be able to pare down and sample over time as you learn the system better and you can figure out the edges.
Mm-hmm.
But then you have all these buckets. You have the raw, you have the silver, the gold, the bronze, the aggregation buckets, the different data stores. And you can just give that to your business intelligence people, your analytics people, your marketing people, your data science people, and they are going to have a field day with this thing.
Yeah.
They want this information. They want to be able to stick it in Power BI. They want to be able to stick it in all these different BI or analytics tools. They want to be able to correlate it, and they currently can't.
Mm-hmm.
You lock it away from them and prevent them from reusing your very expensive data. Well, it's some of the most valuable data in the business. You should treat it like that.
Yeah, I fully agree. I had also like an idea that potentially, like as you said, the event sourcing events are usually rather granular. They are not having a huge size. So, for instance, even putting them into the telemetry and then doing some sampling based on those event types uh, and storing them in some other place, then this could dramatically decrease this size of the data and allow to keep them longer. And so my question around it to follow up on, like, do you think that at least, oh, okay, let's say differently. I I I have a feeling that observability with the open telemetry, it's kind of flattened into the debuggability. I'm not sure if there is a word like that, but we are more focused on debugging instead of observing. And in my opinion, debugging is just a part of the observability. What are your thoughts on that? Like as we discuss, we would like to business discuss like business metrics, business uh, events or triggering even alerting based on, for instance, okay, we see that normally we had at this time, let's say 100 shopping carts confirmed per second, and now we have two. Then this is a
Yeah,
technically a business alert that could be set up in a similar fashion and as let's say those classical ops genie way, but more focus on the business aspects of that.
yeah. So it turns out there is actually a reason for the focus on debugging in OTel, which is that distributed tracing was invented with the motivation of taking that debugger experience of a monolithic system and giving you back that debugger experience in a microservice architecture. That was the motivation behind distributed tracing. So if it feels like a debugger, if it feels like the tools are oriented around that, and the focus is not because we spent, over a decade solving this one particular problem of how do you create a interactive debugger experience for a distributed microservice architecture. And now we're finally going, okay, cool, that's great. But it turns out a lot of developers don't necessarily use that. They often struggle with implementing a good debugger, and it's kind of expensive to do that for the amount of value that you often get that the business
Mhm.
can perceive. So then people are going, well, we have this data and it's useful. And now we're starting to ask, what else can we do with it? But the motivation was originally creating a debugger for microservices. So that's why the focus is there. But in terms of you asked about like the shopping cart and things like that, I think a really fun exercise for domain driven or particularly event architecture people is this question I'm going to ask you. How would you instrument your event sourcing system or your event driven architecture to help you understand whether or not your events are poorly designed or well designed?
Mm. That's a tricky question. So definitely, I would try to. distinguish the specific patterns. Like besides the data that we discussed, then there can be some set of metadata that you would normally want to have, like you mentioned, user ID, commit, the the causation ID or parent ID, the correlation ID, and all that stuff. So we can ensure that at least the events are having those basic metadata, or let's say it doesn't have to be global, but it could be even per business module or business specific type of events, because we know where are they coming from, so it can be different from different type of event. But regarding the regular data, that's much trickier, as we discussed. Without knowing the business context, you don't know whether it is correctly or poorly designed even data. So again, we are
Mhm.
falling into this known unknowns and unknown unknowns stuff.
So how about maybe a more specific one? What if there's this pattern that often happens in an event-driven system where you have one event and it ends up getting used for multiple different things, but each different thing only wants a certain subset of the event. Probably at some point, someone looks at this and goes, this should really be three different events. And then everybody gets happy. Or maybe you have two different events and you always want both,
Mm-hmm.
which is a smell that they should be one event, right?
Yep.
So how do you detect that? How do you actually show that and see if you're using your events and consuming them in the rest of the system in a way that matches the intended usage?
Uh, okay. So, for instance, maybe give you a specific example. I'm not sure if that's what you are asking, but let's try. So, we had a case. I was working on the hospitality management system, and I was in the finance responsible for financial module. And we had a case where someone confirmed reservation, and then we should create this financial account, because after this reservation was confirmed, then this tentative financial account should be created, which eventually should change into the invoicing. And for various reasons, socio-technical reasons, we had a case where after reservation was confirmed, this financial account didn't happen, wasn't created, and that was like unacceptable, because then there is no invoice, there is no money, there is like the main reason why the system exists is not fulfilled. So we had um, a service where we, based on those business rules, we were correlating and aggregating and saying that, okay, if within, let's say, defined amount of time, let's say 5 or 10 minutes, this additional event didn't happen, then that's something bad, and we should raise an alert, or at least show something that this should be handled, or this way or another. At the beginning, the user event couldn't correct that part, and say like, okay, regenerate that for me. There was no feature like that, but some ops people could do something about it. So we were setting up, but it was more like a hand built and case by case, depend based on the knowledge about the business process.
And so that one is kind of an edge case that most observability systems today don't handle,
Hmm.
which is if you have a disaggregated component or distributed transaction, how do you ensure that the entire state machine finalized? And it
Hmm.
turns out that there's no generic nice way to encode a state machine and to figure out if a state machine is making progress and to make sure that it completed. And we don't have any good tools for understanding that.
Hmm.
And also people have to sit there and recognize that it is a state machine. and that you can do this type of logic, and that maybe you should. So are there good, oh, use an observability tool for that? There are no actual good solutions there. But there are ways that you can think about encoding that information such that you can start learning on it. So like what if for every event, and the event is part of kind of more of a distributed transaction, in that event you have an identifier of here's the whole large unit that everything's part of. And then that identifier, you also put the state of the state machine in it. And then you can go and look for, and you don't need to correlate things anymore. You can just look for, select all of the, you know, things where we have a starting transaction state and we don't have a finished state. That'll tell
Hmm.
you everything where something didn't finish. Or maybe then you might go, well, this state and this state, or essentially any state transition, should not take more than 5 minutes. And then you can start learning on state transitions taking longer than 5 minutes. And you can start, and so you can start building this up in a generic way that doesn't require a huge amount of business context, but it's still important to the business. Like you have to put that information somewhere. And that's not a auto instrumentation thing. You just kind of need that information.
Yep.
But you don't necessarily need to encode, oh, that this is shopping cart start. You can just say, it's a state machine with this. You can see abstract that into a library. But that would be a really good starting point.
Hmm. Yeah, there is also a challenge that in OpenTelemetry, you always have this tree structure where you have trace and then uh, spans that are just a child of that. But for many business cases, it's hard to even distinguish. It could be a part of the multiple traces. Like, for instance, shipment. You could say like, okay, it's triggered because someone made a purchase, and then that initiated shipment. But then some other person could say, okay, that's cool, but for me, it's not a part of the ordering process, but part of the inventory process. So from the place where it was put into the warehouse. So that's another challenge for this part because
I
there
actually,
can be multiple contexts of where
right.
this event is coming from.
So with that, the way you typically solve that open telemetry is similar to how you solve the challenges of long-running spans. Long-running spans and distributed transactions are actually the same thing.
Hmm.
And what we're talking about is this distributed transaction of reusable components, and the where it was invoked and why matters a whole lot more than whether or not it was invoked. And so I have an article that I wrote on the new stack actually of
Hmm.
long-running spans and how to handle them. But the summary of different types of techniques you can use for this are generally you can put a property in the span of this is part of this transaction. And then whether or not you were invoked the event at some point, maybe you invoked a order handling event, but you invoked it from the purchase thing rather than from the update. Right. So like, there's different contexts you can have it.
Hmm.
And then so you can put that context in the actual span itself. You might also decide to go and augment the span to different data. You might decide to link the spans because there's a linking functionality. And you can actually create a span, pass it the parent, and then create a link to it. Or you can create the parent and pass in a link to the child, and you can do that sort of thing. You can create casual links. You can use the attributes. You can do an actual linking thing. You can, if you really want to, you can rewrite the trail a little bit. I don't recommend doing that because it's fragile and terrible. But you can, and then you can. There's other techniques you can use,
Hmm.
but that idea of how do I correlate it? And rather than thinking of does it have to be this, tree form?
Hmm.
Because it does really want a tree form, but it's more how do I correlate things? And the tree form is implicit correlation. but you don't have to have an implicit correlation. You can have an explicit one.
Mm. Yeah, yeah, I like it. So unfortunately, the magic is that there is no magic, and we need to really understand the business and know um, what are our business process or core important from the business perspective, as you underlined multiple times, to be able to properly have this observability. So unfortunately, I mean, because open telemetry is always advocated, or most of the time, with this unknown unknowns and focusing that you never know what can happen. But a lot of time you just know more or less, or even to be able to store meaningful data, you need to know to some degree. And we are slowly getting to the closure, but I wanted to ask you, what's your take on metrics? Because I see that many observability people are saying, nah, don't use metrics. It's the old-fashioned way. We don't do metrics anymore. We just query telemetry data. What's your take on that?
So I actually have a different take on that for most of the industry. I like metrics. I like logs. I like traces. I like all the things. And I think that they are all useful. Traces become exponentially more useful the more data that you store in them. And traces can be used, and white events can be used to derive a lot of metrics data from it. So if you're in a situation in which you want aggregations of data, and you can derive those aggregations meaningfully and usefully from your white events, go ahead and do it. Those are still metrics. You can call them that. It's okay. But if you're in a situation where maybe that doesn't make sense, for example, system performance or performance profiling or monitoring your hard drives or servers, other properties like that, or it's a continuous value over time, getting a discrete chunking of it doesn't make sense. The continuous value over time, that makes sense. And then how you those discrete chunks is some type of application. It's a perfect tailor-made. This is exactly what you use it for metrics. Any continuous value that you want to summarize or aggregate and represent statistically is a metric, which means that service level objectives are a type of metric.
Yep.
So all the people that say, oh, metrics are terrible, but then also praise the value of service level objectives are doing this loop around, talking bad about the thing that they praise because they're viewing it from the wrong perspective. A lot of the times when you talk negatively about metrics, it's really when you're trying to use metrics for things that it doesn't work well for.
Mm-hmm.
And one of the weaknesses of like having metrics and traces and logging and all these different pieces of data is that often you don't correlate them. Often you can't query across all of them. You can't reconcile between all these different things. And if you're ever in a situation in which you want to ask a question and it requires you opening up multiple different tools and looking at multiple different things and then kind of trying to eyeball it together in your head, you are fighting against your tooling. And that's where a lot of the negativity of logging and metrics and statistical analysis and these sorts of aggregated data streams come from. But that being said, a lot of the modern observability tooling doesn't actually help solve that problem. They do the same pattern, but they have a lot more flexibility because they focus on white events. And you can put a lot of your metrics data in the white events, and you can start to create metrics from white events. So you can get some of that. But the actual, how do I correlate heterogeneous data streams is something that nobody has ever done. And that is at the heart, technically speaking, of what Observability 3.0 it's one of the enabling factors of Observability 3.0. Having heterogeneous data sources, correlating between them, then having heterogeneous data destinations, and having, this concept of continually changing the data, refining it, doing things with it over time, creating
Mm-hmm.
views, creating queries, creating, do this multiple in, multiple out, multiple forms, multiple views, multiple. It's a different type of slice and dice.
Mm-hmm.
But if you have just one single data format, you can slowly reinvent a lot of that from scratch with a data, database that you don't control, with a bunch of other things that you don't control, with a bunch of weaknesses that are hard to, get over, or you can embrace multiple data sources aren't bad. Multiple, data destinations aren't bad. Multiple views, multiple perspectives, none of those are bad. What you do need is a really flexible and powerful way to correlate things.
Mm-hmm.
Once you get that, and once you enable that, and once you create the flexibility for people to do that in a way that plugs into existing workflows and helps enable new ones, that's where you get that business context. And when you take the business context and the understanding of it and embed that into how everyone sees the system and make those synonymous, that's when you get that observability 3.0.
Yeah, that also really sounds similar to, again, to the premises of event sourcing, because then you are recording all those and capturing this business intention, and as the events are kept, let's say, forever, which is not actually forever, but until you need them, then you can build those representations, so read models depending on your current needs. You can throw them out if you don't need them. You can fine tune them, create them on flight if you have enough resources to build that in memory. So yeah, it's really aligned with also how I see stuff. Um,
Mm-hmm.
Let me check if I have some more questions from the community, just to double check, but I think that we covered most of them.
Mm-hmm.
Uh, it was really,
Mm-hmm.
really, yeah, we actually did. So I really, really enjoyed that. It was really super practical. So one final question, like, would you do something differently in if you were like younger Hazel fighting with the initial Hekiderm issues? Would you do it something differently in terms of observability, or could you do something better to not like wait this 1 week, as you mentioned, with trying to understand and correlate data? Do you have something
I
in
think
mind?
the main thing that I would have done differently is there were two weaknesses that we ran into that made it hard to understand the system.
Mm-hmm.
One is that we didn't understand it. There's no information on how to understand it, really. And that's just not really solvable. But like the important one was really that we didn't have a lot of our observability and monitoring and things like that set up before the incident started. And we actually had to set it up partway through, which is fine. We had some of it set up and then we added more and we were fine and we kept adding more. Um, but something that was really crucial was we had no understanding of the baseline. We had no understanding of the expectations. So we were looking at numbers and we were looking at the graphs and the charts. And if you don't know, this is a bad number, this is a good number, this is a great number, they're just numbers. So we had, for example, disk monitoring. Did we know we can trust it? I don't know. So can we trust the data? Was one of the things. I would have made sure we could trust it. And then can we understand and contextualize the values in terms of, you know, good, bad indicators? Like, can we tie the metrics, the observability, the logging, everything into a, inference, into a, intuition of, is this good for the system? Is this bad? Like, how representative of it is it? Those are all things that we didn't really have. And so the incident was essentially, let's learn the system, let's build that intuition, let's keep it alive when we do so. And then when we had the intuition, the observability, we kind of knew how to test things, so we had the parameters. All of a sudden, the solution falls out. And it's, oh, this is a failing. And I know that that's a problem now because I've seen the rest of the system. I've gotten this intuition. I've figured out a lot of the bottlenecks. And these numbers are really, really slow. These numbers are really small, and I can kind of trust them now. But before we were getting like zero IOPS for so long, or we were getting like maybe 10 or 20, and I'm like that number is so small. Is that real? Turns out it was. Um, but like, is it bad? I don't know. Is that an overloaded disk? Is that a? It turns out they're failing. Cool. So, but now that we knew that, we could look at the numbers and go, oh yeah, and then we could check things. And then, but knowing the baseline is something that I would have done before. If we had
Mm,
been able to maybe set up a known working server, like a known perfectly operational one, duplicate the monitoring and everything to there, then establish a rough baseline, and then look back at our working operational system and notice that the performance is 1 to 10,000 times slower in certain areas. That's an anomaly. That's, an outlier. That's useful.
mm,
We had to rely on developing enough intuition and understanding that the observability that was set up was functional, and then finally knowing where to look. And all three of those are really hard, and ideally you don't want to have to do that. But you're gonna need to know how to trust the numbers. You're gonna need to know the range of them, what's representative, what's not. And so learning that sooner rather than later, really important. I would have done that first.
mm. Yeah, the reason why I ask because this story really reminds me a lot of project that where having some people are calling good problems to have, so kind of being successful, although you were just doing that for the community. I mean, just so when people are starting with their idea, it works for the first initial customers like friends and family, but then the real traffic comes and you realize that you don't know what you're doing. So thanks for those insights. And in general, I can tell that you were doing that really well. I was looking on those streams and I really like Postgres, so I was observing what you're doing, and it was still impressive that you managed to keep it alive. So that was like a primum non nocere, how the doctors are saying. Okay, so Hazel, once again, thank you a lot for being a great guest today and sharing all that knowledge. I'm really impressed, especially that I felt that I'm a guest at some point that I'm a guest and you are the the showrunner. But I enjoy it. So thank you a lot from me and from the Architecture Weekly subscribers.
Absolutely. It was glad to be here. It was fun to be here, and I was glad to do this with you. It was a lot of fun.
Yeah, and if you're watching that, then below you will find all the links to the stuff we discussed and really follow what Hazel is writing and showing because it's really not only in terms of observability but also leadership, etc. Always enjoy the content. Okay, so thank you, Hazel, and yeah, leave us a comment below on what are your thoughts.